Vector quantity.
Yes, it's a vector quantity. Can you describe how acceleration is a vector quantity?
Because it has direction and size.
Yes, this has uh, direction as well, because you can see in the definition of acceleration, basically acceleration is the change in velocity, because velocity is a vector quantity, and if there is some change in velocity, which is acceleration, so acceleration is also a vector quantity. Okay.
Mm-hmm.
Yes. So basically, acceleration describes how fast your bodies will move. Okay, as you know, this is a vector quantity, and we will also discuss later that what are positive accelerations, what are negative accelerations. Before that, let's clarify the unit of the acceleration. So,
Mm-hmm.
acceleration units can be understood by their formula. So, let's first check what is the formula of acceleration. As I mentioned you before, acceleration is basically the change in velocity with respect to time. And change in velocity basically means final velocity minus initial velocity. If your body is moving, is in motion, so they must start with some initial velocity, initial speed, and they have to stop. And whenever your body stop, that type of state is called as the final velocity. And in change in velocity basically describes by final velocity minus initial velocity. So here you can see small a and acceleration, which is denoted by small a, which is equal to the change in velocity, which is described by v minus u, whereas your v describes the final velocity. Okay, and this u describes the initial velocity. Okay.
Mm-hmm.
The change in velocity, which is final velocity minus initial velocity, over time is so called as the acceleration. Okay.
Mm-hmm.
Okay. So now let's check out what should be the unit of velocity. Can you describe what is the unit of velocity?
Uh, Meters per second squared.
Yes, meter per second square. This is the unit of velocity. As you know, the unit of acceleration is meter per second. Okay, but here you can see the unit of the velocity is meter per second square. Okay,
Mm-hmm.
okay. Now there are two types of velocities. Those velocities are called as the positive velocities and negative velocities. Basically, positive velocities move means that if your body is accelerating, okay, in positive direction, if your body is moving in forward direction, if your body
Mm-hmm.
is moving in forward direction, means the acceleration is positive. And if your body is moving in opposite direction or in negative direction, basically negative means your body is now slows down, and positive means your body is now moving with high speed, moving fast. If your bodies are moving fast, you can say the acceleration is positive. And if your bodies are moving slow, you can say the acceleration is negative.
Mm-hmm.
All right. So if
Mm-hmm.
a car,
Yeah.
let's suppose if a car is moving with an initial velocity of 10 meter per second square, and after 5 seconds the speed is 15, and after 10 seconds the speed is 20 meter per second, and after 1 minute the speed is 50 meter per second. So can you tell me in that scenario the acceleration is positive or negative?
Positive.
Yes, positive, because at every instant your velocity got increased. Okay. And if a car, let's suppose, is moving with initial speed of 50 meter per second square, and after 30 seconds it got 30 meter per second square, and after 1 minute its speed drops to 10 meter per second square, can you tell me in that scenario which type of acceleration is that?
Negative.
Yes, negative acceleration. Good. Okay. So let's move on towards the types of acceleration. Okay.
Mm-hmm.
Okay. So there are some types of acceleration, which I already two types I mentioned you before, which is positive acceleration and negative acceleration. Positive means if your body speeds up, you can say positive, and if your body slows down, you can say negative acceleration. And the third one is the uniform acceleration. Same which we discussed in the uniform velocity, same concept you have to use in uniform acceleration. So how can you describe uniform acceleration is that if your bodies are accelerating with constant velocity, means their velocity would not change. Their velocity will remain same. It means if your car is moving with 60 meter per second velocity, their velocity remains same at every second, at every time. Their velocity would not change. If their velocity would not change, you can say the acceleration is uniform acceleration. Okay,
Mm-hmm.
let's suppose you will drop a ball from some height, and from if you drop a ball from some height, the ball will move downward, right?
Mm-hmm.
Why the ball moves downward, not upward? Can you tell me?
Because gravity
Yes, this
pulls
is
it
due to
downward.
the gravity because gravity pulls down. Okay.
Mm-hmm.
And do you know the value of gravity? What is the value of gravity?
Sorry?
What is the value of gravity, of our Earth's gravity?
9.18 or 81
Yes, 9.8 meter per second square. Okay. So what is the unit of gravity?
meters per second squared.
Yes, the same unit for acceleration, the same unit is for gravity because gravity is also sometimes called as the acceleration.
Mm-hmm.
Okay, because whenever bodies fall under the action of gravity, they are accelerating, they are moving. So whenever body is moving, you can say those are in acceleration. Okay, so gravity are sometimes also called as the acceleration, and gravity acceleration are called as the gravitational acceleration. So if there is
Mm-hmm.
no change in velocity, then you can say this type of motion is called as the uniform acceleration. And now move on towards the fourth one, which is non-uniform. As the name stands, non-uniform. So it means if your acceleration changes continuously, not remain same. If your acceleration changes continuously, not remain same with respect to time, you can say this type of acceleration is called as the non-uniform acceleration. Let's suppose if you are driving a bus in some traffic. So sometimes you increase the acceleration, sometimes you decrease the acceleration, sometimes cars speed up, sometimes slow downs. Your acceleration would not remain same, not specific value. It continuously changes in. Okay. So this type of motion is called as the non-uniform acceleration. All right. Now move on toward the last one, which is the centripetal acceleration. Okay.
Mm-hmm.
Centripetal acceleration basically means that if a body is accelerating in a circular path, okay, if a body is moving in a circle, this type of motion is called as the centripetal acceleration. Acceleration that causes an object to move in a circle. Okay, example in front of you is that Earth orbiting around the sun. You know that Earth is orbiting around the sun. So Earth is revolving around sun. So this type of motion is called as the centripetal acceleration. Also, you know that Moon is revolving around the Earth, right?
Mm-hmm.
So this
Yeah.
acceleration is also called as the centripetal acceleration. So whenever body is moving in a circle, this type of motion is called as the centripetal acceleration. So basically these types are the types of acceleration. Do you have any question?
No.
Okay. So can you tell me if a body is moving, if a body's speed increasing, this type of motion is called which type of?
Positive
Yeah.
acceleration.
So yes, if your velocity is decreased, this type of acceleration is called.
Negative acceleration.
Yes. If your velocity remains same with respect to time, this type of acceleration is called.
Uniform acceleration.
Yes, and if your velocity is not constant, it changes continuously. This type of acceleration is called.
Non-uniform acceleration.
Yes, and if your bodies are moving in a circle, this type of acceleration is called.
Centripetal acceleration.
Yes, centripetal acceleration. Good. Okay, now just wrap up this section and move towards the next topic. We will discuss about work examples. Okay, some practical
Okay.
examples how we can calculate acceleration. So, example number one, you can see a car increases its velocity. So, can you tell me it says a car increases its velocity? This means which type of acceleration?
Positive.
Yes, positive. Good. So if a car is increasing velocity from 10 meter per second to 20 meter per second, means this velocity is the initial velocity and this velocity is the,
Final.
yes, final velocity. Car initial velocity is 10 meter per second and car's final velocity is 20 meter per second. And it how much time it takes? 5 seconds. They are
Mhm.
asking you to find the acceleration. Can you find acceleration? Yes, you can, because you know the formula of acceleration, which is final velocity minus initial velocity over time. Final velocity is given, which is 20, and initial velocity, which is 10, just minus divided by what's the time?
5 seconds.
5 seconds. So 20 minus 10, it becomes 10 over 5, and the answer is 2. And what is the unit of acceleration?
Meters per second squared.
Yes, meter per second squared. So this is how you can find the acceleration. Do you understand it?
Mm-hmm.
Perfect. Now move on towards the second example, like a train slows. Basically, this describes,
Negative acceleration.
yes, negative acceleration because your train now slows and the train slows from 25 meter per second to 5 meter per second. Means the initial velocity of train is 25 meter per second and now final velocity is 5 meter per second. And the time it takes is 10 seconds. And they're asking you to find the acceleration. And you know that to find acceleration, formula in front of you is that final velocity minus initial velocity. Final velocity is 5, initial velocity which is 25. So 5 minus 25, it becomes minus 20 over 10. Minus 20 over 10, it becomes minus 2 meter per second square. All right.
Mm-hmm.
As you told me before that this is basically describes negative acceleration. That's why you can see here is a negative sign. All right.
Mm-hmm.
Basically, this negative sign describes your acceleration is negative. And if your answer is in positive, you can say this type of acceleration is positive acceleration. Because this is negative acceleration, that's why the answer is also in negative.
Mm-hmm.
Okay, now move on towards discuss about the real life applications. Basically, in real life applications, you know that we use seat belts in our cars. Why?
Uh, so that we
Mm,
don't go through the window.
mm. Okay, I think 40 minutes is just time's up, and in 1 minute again meeting should stop. So if that stop, you can rejoin. Okay,
Okay.
it just gave me 1 minute more. So okay, so can you tell me why we use seat belts?
So that we don't go flying through the windows.
Yes, right. Because car is accelerating with very high speed.
Mm-hmm.
And if we got an accident, so we must have to reduce our acceleration. So to reduce our acceleration, that's why we use seat belts, right?
Mm-hmm.
Seat belts requires us to reduce the acceleration. Whenever car hits, all the acceleration damped by the seat